All right, so simple search with Elasticsearch. Elasticsearch has nothing to do with Amazon Web Services. The Elastic part is the total, yeah, it's a red herring. There is no Amazon anything with Elasticsearch. It's actually a server you run locally. So the Elastic part actually refers to the scaling system that they've built into it. So if it's not Amazon, what is it? It's Java-based, but thankfully, unless you have really custom requirements, you won't have to write any Java. You won't even have to know that it's Java because it doesn't, you just turn it on and it runs, and you turn it off if you need to, and it stops. There's no Java guts that you have to rip open. It's based on Lucene, so that means it's similar to SOLR. So if you're used to how SOLR does search, you'll probably be used to how Lucene, Elasticsearch does search. It's a document-oriented database, so there's no SQL. With that said, it's not a schema-free system. You can avoid making schemas, but you can't take advantage of any of the really advanced features of Elasticsearch without defining your schema first. And in Elasticsearch, they're called mappings, and we're going to get into mappings a little bit later. It's also really fantastic for search, because they put it in the name. That makes it good. And it's really easy to set up and use. I've already pre-downloaded it to avoid the demo pain of watching me download files. But I am going to start it up. We're going to do some curl requests. We're going to, use it because live demos are the best. So the two main things you have to understand for Elasticsearch, there's three, but we're going to do two now and one later. The first two are indexes and types. So Elasticsearch is built around the concept of having multiple indexes. This allows you to do a bunch of things. You can host many types of Lucene indexes in Elasticsearch simultaneously, and each one of those indexes can hold multiple types. So if you think about it, an index is similar to a database of search stuff, of documents you want to search. But a type is like a table. So a type is two things. It's a mapping, which is like a schema. Basically, it is a schema. And the other part of it is all your data. And so if you think of it in like a relational database, you have indexes, which are databases. You have types, which are tables. And then you have schema, which is a mapping. Well, you have mapping, which is a schema. They're basically interchangeable in Elasticsearch. So it's a document-based REST API. So we learned a little bit about REST yesterday from Mark Eep's talk. And Elasticsearch is all REST. You can do everything you want with Elasticsearch from command line, or curl, or if you have like a browser plugin and you want to use the, what is it? There's a browser plugin that got demoed about how to use, do curl requests basically from your browser. You can do that as well, but it's basically all REST all the time. There's no other way to talk to it. And the config files are all done in YAML. But you don't really have to use a ton of the config, because once you start up the server, you can start configuring it with curl. You can also configure it with the YAML file if you want to skip that. And it has a bunch of sensible defaults that work pretty well out of the box. So before I do the rest of the demo, I'm going to start up Elasticsearch. So I've downloaded Elasticsearch. Is this big enough? Make this one bigger. So I've downloaded Elasticsearch. It comes down as a tar file. You open up the tar file. Inside of it is a bunch of directories. Inside the bin directory is the server that we want. The F puts it into interactive mode. The D lets you declare a bunch of environment variables. So I'm just telling it where my Elasticsearch config file is. You don't have to give it a config file, then it starts up with no config file. I'm using the config file that comes with Elasticsearch. I moved it out so I could read it. So we're just going to boot it up. And the output will be very unreadable. So by default, I have it configured to start one node. So a node is a server. The idea behind Elasticsearch is that it's a clustered service, so that you may have one to infinite number of nodes running, and those nodes can host a number of indexes in a number of different ways. By default, it only starts up one node, and you can see that last night I was doing some testing, and there's an index stuck in the cluster. It also gives the clusters fun names if you don't give them names. So I'm just going to clean out that old index. I'm just going to use curl. By default, Elasticsearch runs on port 9200, which makes it really easy to get to. The index I'm using for this demo is called contacts, because it's going to be like a search index of people. So I'm just going to delete the index. There's no confirmation, so be very careful when you're using delete commands, because it's all gone. If you had 1 million records in your database, they're all gone. The other thing you have to remember with Elasticsearch, if you're deploying it to production, there's no authentication. None, zip, zero. Put it behind IP tables, or some joker will come by, ask Elasticsearch what indexes there are, and then run curl, delete them all. All your data's gone. So, yeah, pro tip, run Elasticsearch behind IP tables, or put it on a VPN. So now that Elasticsearch is running, we're going to create a document. So I'm just going to copy this and drop it into Elasticsearch, into curl, which is going to index a person. So there's two parts here. There's the index, which is contacts, and then there's the type, which is people. Right now I'm not creating a mapping, so what that's going to do is Elasticsearch is going to do a best guess and create an implicit mapping, and it's going to use the types in the JSON to guess at what my types are. Thankfully, my types are all strings, so it's pretty easy for Elasticsearch to figure it out. I'm going to get into the data types that Elasticsearch supports later on. So we're just going to create that. And Elasticsearch says, OK, true. If it says OK, false, your request failed. Tells me the index it made it, tells me the type it made it, and it gives you an automatic ID and also a version, because the way Elasticsearch resolves conflicts is by version numbers, and you can also update specific versions, you can delete specific versions. If I was to go and delete this document, then it would create another version until it got propagated to all the nodes. All right, let's read back the thing we just made. So we're just going to read it back. I need the ID. One of the nice things with Elasticsearch is when you're using it command line wise is you should always put the pretty equals true argument on. That will make it format the JSON into a mildly human readable format. Otherwise it just gives you a gob of JSON and you have to deal with it yourself. So we can get the data I just put in. You can see it's part of the contacts index. There's a people type, there's an ID, it's the version. It says it exists. If you do a get for an ID that doesn't exist, it says exists is false. Source is the original source document that I put into the database. There are ways to tell Elasticsearch to index certain fields but not store them, so that when you retrieve a document, it's not part of the source thing, but it shows up as part of it's used as part of the search index system. You can also not store the original document if you don't want to build a large document database. So you can do that as well. So that's the get. Now we're going to delete it, because deleting things is fun. So we're just going to go back, just change the HTTP method to delete, and now it's gone. So it said it found it, said it's OK. If we go back and try and get it, it says exists is false, so that means it's gone. Yeah. So that's pretty simple. You can also do really simple search. So if I go back and create it, so I made it again, and if I go back and just search, you can do very basic search and very, very advanced search in Elasticsearch. You have two options. You can just use a query string. So here I'm just looking for my name. Can't really see the highlight very well. Yeah, it shows up OK. So that's one way of doing a search. That's going to search every field in the type in the index that I've specified. You can also do far more customized searches with request bodies. And you can build up giant query strings, but if you're going to do anything more complicated than just a little joke query, you should probably use the content body. So I can do a search. You can see it took 46 milliseconds. It didn't time out. It hit all 5 shards. All 5 shards were successful. We're going to get into sharding a little bit later. None of them failed. There was one hit. The maximum score, it's based out of 1. So it tells you the relevance, so you can do relevance-based searches. There was one hit, and then it lists out the hits that it found. So this is a single document inside the hits list, and then the hits list will have all the documents that matched your search. So when you get a response back from Elasticsearch, you kind of strip off all the padding and then go into the hits, and then that's the documents you actually wanted. Does that all make sense so far? So that's what a kind of a response looks like. I formatted a little bit better so you can see the shards and the hits. So then there's hits, and it tells you the max relevance. So this all sounds pretty badass. We have a basic document database. We can put stuff in. We can get stuff out. We can do really powerful searching. Why wouldn't I just use this instead of every data store? Because searching is one of the most common features that end users really want. They want to be able to do full text searching. And if you've ever who's implemented full text searching in MySQL? Yeah, how much fun was that? No fun. So why wouldn't you just use Elasticsearch for everything? There are some downsides to Elasticsearch. There are no partial updates are possible, but they're hard. Even when a partial update is done through sending a magic script, and then you can write some JavaScript, or it's Lua. I can't remember if it's JavaScript or Lua. They always look the same. And you can update one field or two fields. But the problem is that Elasticsearch is going to re-index the whole document. So even if you do a partial update, it's just going to re-index the whole document. So you have to always do a full update. And you do updates through put. So you have to just get the document down, do a put. It's going to re-index that document. So partial updates are kind of a pain. There's no joins. You cannot join between two indexes. You can search two indexes at the same time, as we'll see later. You can also search multiple types at the same time, but there's no joins. You can't join your people type onto your organization type. It's impossible. There's also no MapReduce. So if you're used to MongoDB and you could MapReduce out an aggregate function, can't do that in Elasticsearch. There's no MapReduce. There are, however, facets, which allow you to do some interesting aggregation. We're going to get into facets later. So it does have some limitations, but all in all, the search is pretty damn amazing. I'm only going to cover a few of the search filters and search queries that you can do in Elasticsearch. The documentation is huge, and every single search option has examples that you can just copy and paste and run. So I'm just going to show you all of the search options that you can get to. So if you go to the elasticsearch.org site, you can go to the query and then the reference guide and look at the query DSL. And then all of these things on the side are all the different types of queries you can do. So it just goes on and on and on and on and on. And then all of these have more sub-options. So it's a pretty powerful DSL. And it also handles geodistance data. If you notice, there's some geo stuff, so you can actually do geolocation services. And you can do really cool stuff with, you give it a bounding box and it can find results in the bounding box. You can draw a polygon, it can find data inside the polygon. It can also do, if you're doing a faceted search, you can do geodistance, so you can give it a point, a lat long, and it will give you things based on ranges echoing out from that point, so you can find, restaurants near me, restaurants within 10 kilometers, restaurants within 50 kilometers, restaurants within 100 kilometers, and then you can find out the aggregate number of searches from there. So it's amazingly powerful. So you can search between types and indexes. If you want to search more than one type, you can just make a comma-separated list of types that you want to search, and it will search both types. You can also search multiple indexes in your cluster. So if you want to search every index in your cluster for every type, every people type, say you have the people type in more than one index, because you have a small multi-tenant situation, and you want to search my people and Mariano's people and Jose's people, you can use the magic _all, and it will search everyone's contacts all at once. So if you're building some sort of back-end administration system, you want to see how many times Walter's in the database, you can do that. So there's lots of fancy search options. All the search options are submitted to Elasticsearch as JSON through a content body. So it's really easy to do in curl. But before I can do any useful searches, I'm just going to insert a little bit more data. This is just going to create 4 more documents so that I can do a little bit of searching. So here we're going to do a search with a query string. Query strings support all the Boolean operators that you would normally use. So you can use OR and you can use boost. So if you use a caret, you can boost certain terms by certain percentages. So if you want to search for Mark or Graham and you want to make Graham more important, you can put a caret and then 0.5. So you don't have to expose that to your users, but you could, and give them a really powerful search language. So we're just going to run that. And there we go. So you can see here that it took 11 milliseconds, so it's pretty fast. It's running on my Mac, so that's not really a powerful use case. But I've talked to people who have used, I've loaded up over 1.5 gigs of data into it, and the searches still take like 35 milliseconds, 40 milliseconds. So Jose's got a couple 100 gigabytes of data into it as well. So you can see the hits. There's 2 hits. Max score was 0.19. And then it gives you the source documents back. So you can find the actual source documents. And you can see that it's preserved the array types that I've put into it. So that's pretty powerful if you're building like a simple object with tags or an object with some sort of category, like has and belongs to many. You just denormalize the data, dump it into Elasticsearch, and then you can do searches on it. So you can also highlight search keywords. So if you've ever seen Google, back in the day, they used to like put yellow text around search terms. And we do that in the cookbook as well. So if you search on the cookbook, we italicize the search terms that you're looking for. And we do that just with native features in Elasticsearch. Whoa. Now comes the fun part. Oh. So you can see here, I clicked it and ran it. I got an extra carriage return. So there's the search. So I'm searching for text, the word, the term, mark. I'm going to highlight all the fields in the email. I'm going to highlight the email and name fields. The empty objects allow you to provide in more parameters. So you can say what string you want it highlighted with, what kind of slop you want on the words, whether you want it to like, go around a word or wrap the whole word, even if it's inside the word. You can do like the number of times it's going to pull out a fragment. You can specify the fragment size. So if it finds, you search for mark and then it's in a huge paragraph of text, how much text around it you want to excerpt out. So this is all controllable through the JSON API. So it took 22 milliseconds. The max score was 99.99, which is a pretty good score. That's one of the higher scores I've gotten. And then you can see here that it's already pre-highlighted all the text. So if I was just going to dump this into a web page, boom, highlighting's done. Didn't even have to do any work. All right, facets. Has anyone ever tried to build, like, you do a search, and then on the side you want to show, oh, there's this many results in this category, and there's this many results in this category, there's this many results in this category, or a tag system where you're saying, you search for, bananas, and these are the 3 tags that also have bananas on them. This is usually complicated in MySQL. You have to do a search, find the tags, take that tag ID, go back into the tag join table column, join table, do another query, find all the occurrences, group them, and then reformat that data, stick it back down. Ugh, it's a lot of work. Elasticsearch makes that really, 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 really easy. You just ask it, give me some facets, and it says, sure. Here you are. You can do facets on a number of different things. You can do it on term counts. So you can say, find me all the tags. Give me a histogram of all the tags that also came out of this search. You can do it for a custom script. So you can provide some JavaScript and say, I want to run this script on every single search result and turn those into facets. You can do ranges. So you can say, I'm looking for computers, and I want to group them by cost ranges. So between $0 and $100, $100 and $250, $250 to $5, and then more than $500. And then Elasticsearch will just bucket them and store them back. You can do the same thing for geodistances, as I mentioned earlier. You can do a search based on a lat long. Say, give me all the geodistances from 10 to 25 kilometers, 25 to 100, and so forth. And it will just generate all the facets for you. So to get facets, I'm just gonna do a simple tags facet. We're gonna search the people type in the context index. We're gonna query, we're just gonna look for star.com, which is an email address. We're looking for people who work at a .com or have a .com email. And then the facets we're gonna want to have a tagged facets. So you can also ask for multiple facets on the same search query. So if you wanna facet your data based on tags and price and range, so I want to find contacts that are near me, I can do tags and geodistance, and it will give me both facets at the same time. And I'm just going to do a simple terms facet. There's other facets you can do. The documentation has all the examples. The terms one's the simplest one. It's most useful for tags or if you've created denormalized categories. The geodistance one is probably also a pretty popular one, I think, just because it's really powerful. And we're going to do the terms aggregation on the field, name tags. So there it is, it's already done. That's how fast it was. I only have 4 documents, to be fair, but it took 21 milliseconds. You can see that it found max score was a perfect match. There's 4 hits, so you can see it gives you the source documents if you want to ever give the search results, give the facets. That all comes out as one response from Elasticsearch. So we have all the documents, and then we have the facets that we did. So there's the tagged facet, tells me the type, tells me how many terms it matched, and then it gives you the counts for each term ordered by count. You can also change the ordering, so you can do a reverse sort, you can do a forward sort, and then it gives you the term, the count, the term, the count. So wow, your facet navigation's already done. You just create some links. When the link comes back, you parse that, turn it back into Elasticsearch. You can create a drill down search. Boom, that was easy. Well, I'm obviously making it a little bit more easy than it sounds, but it's fairly straightforward from here to get to a drill down search. You can also see that all the terms are, you can see all the queries running in Elasticsearch as well, which is kind of nice if you're just monitoring it. So there's tons of knobs and buttons and little status things you can ask it about, and they're all documented fairly well. One thing I find with the Elasticsearch documentation is when you're looking at the query DSL, always remember that the query things go inside the query tag, like inside the query object. Otherwise, Elasticsearch will just yell at you and be like, I don't know what you're talking about. I'm going to parse error on this. And so once you remember it has to go inside the query, then you're usually a little bit better. So mappings. You should always declare your mappings before indexing your documents. If you declare a mapping after you index some documents, Elasticsearch will delete all your data, which is kind of a jerk move.
Well, actually, it will complain that it cannot merge mappings.
Yeah,
if you do one mapping, you need to delete it.
Right. Yeah, it's kind of a jerk like that. So always think about your schema ahead of time. It's a little bit like a normal database. It's not as schema-free as like something like Mongo, but you get really, really super powerful search options. So mappings can be used to do a lot of things. They can declare the types, so that changes how Elasticsearch stores things internally. You can also change how things are indexed. So if you're indexing, Japanese and English documents in one database, you can say, analyze this text as Japanese, analyze this text as English, analyze this text as Spanish, and then it will change the stemming rules that it uses so that when you search for, bag, it finds bags as well. You can disable indexing on certain fields. So say you have fields you don't want to go into the index results, and you just want to be able to do cached filters against. You can do that as well. You can also configure custom analyzers. Jose was telling me about a thing they use at SeatGeek where they have custom analyzer. They wrote a custom analyzer in Java for a specific field so that they can do related artist searches. So you can actually create custom indexing solutions with just a bit of Java code. So the available mapping types, there's actually a fairly powerful set of types. You have your basic types, which are the core types, which are string, integer, float, boolean, null. You also have object, which is a standard, so you can put nested objects inside of it, and Elasticsearch treats those as objects, and then you can search through those as well. Any array containing a core type is automatically handled, so if you declare a mapping as a string, and then you also give it an array of strings, it will index all of that as well. So that's how the tags thing worked earlier. Properties can be defined on objects, so then you can declare submappings. You also have more mappings. There's multi-field, which allows you to index a field multiple ways. So you can have it as an unmutilated, you can have it as a different, you can give a field 2 aliases and have them indexed differently. You can create nested, which creates sub-objects, which allows you to do searches based on dot notation. So you can drill down and just search on those nested objects. You have to be careful when you do nested objects that you don't, it creates a weird cross-join type situation, so you might want to avoid it. You can do types for IP data, geopoint data, so that's a lat long. You can also do attachments, which is a pretty crazy feature. I just found out about it. I didn't know that it existed. I think they added it recently, I'm not sure. But anyways, if you index a text-based document like a PDF or an Open Office XML file, not the Open Office, the Microsoft Office XML files, or a text file or an RTF file, Elasticsearch will index all of that too. So you can actually search through blobs. So at least that's what the docs say you can do. If it works as advertised, that's pretty amazing. Because you can build, if you're doing like simple file storage and people are uploading PDFs, let's just index all of that too. And you can search through people's email. pretty awesome. So to create a mapping, I'm just going to do a mapping that doesn't conflict with the existing one, and hopefully Elasticsearch will not yell at me. So you declare the people mapping. We're going to put the people type in. These are the properties for the people. You can put a type and then the string. You can also go in here. The next slide has some more information. Yay. And then we can do a search. It didn't delete all my data because the mapping I gave it matches the way that it internally mapped things. So it's only when you create a mapping that doesn't agree with the auto mapping that you have problems. So always do your mapping first, and then you won't have problems. When defining a field, you can declare which analyzer you want to use. There's several built-in analyzers. It defaults to the English one. You can control it by the config file. You can also have different indexes, use different analyzers by default, which is all configuration options. And you can also configure things as you set up an index in Elasticsearch. So you can have different analyzers for indexing a field and a different analyzer for when you search a field. So when a query hits a certain field, the query gets parsed in a different way. So it's pretty powerful. You can also create all of these extensions. If the analyzers aren't in Elasticsearch, you can create custom analyzers with some Java code. And it all just hooks into Lucene. So if you know how to build plugins on top of Lucene, you know how to build plugins on top of Elasticsearch. You can also disable analyzation and indexing of certain fields so that they don't pollute your results. So if you want to make it not analyzed, then it will just store the text. And if you want to turn it all off entirely, you just say no, and it won't even index those fields. You can do filters by them, but you can't do searches on them. Shards. Go smaller. Okay, shards define, because Elasticsearch is a clustered-based service, the way that they do the scaling is through the ideas of shards and nodes. So a node hosts many shards, and shards and replicas. And nodes can host one or many shards and one or many replicas. Storing multiple replicas in a single node is kind of a silly idea because you're just consuming more process power, more resources to basically get no advantage. However, hosting many shards in a node is pretty oftenly done because you can't reshard your data easily. You have to make a new index and then reshard it. So that's one downside as well that you have to be careful. The idea with shards is that if a node goes down, you still have some of your data. If you only have one replica and a node goes down, you'll have part of your data. You can also use routing, which is a more advanced feature to decide how sharding is done. So if you only want certain data to go over to this shard, which is hosted on this node, you can define a routing that says things matching these fields should go over here. Fields matching these terms, like fields that match these criteria should go over to this node. So you can actually manually control the sharding. By default, Elasticsearch comes with 5 shards, and it just manually goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. More shards across multiple nodes improves your indexing performance because documents get put into one shard, get indexed there, and then get propagated out once they're indexed to the other replicas. So basic sharding, you have a server or a node which runs multiple shards. So you have 1 shard, 2 shards, and 3 shards. That didn't work. So you can kind of see at the bottom, there's ID1, ID2, ID3, ID4, ID5, ID6 in this shard. So if later on I wanted to rebalance my cluster, I could put up to 3 nodes and have 1 shard on each of them, and then each give them 2 replicas. And then they'd all have, I could lose, I think, 1 node, and I'd be okay. You can also shard over multiple nodes, which is what I was just talking about. You could have multiple shards. So if you had 4 shards, you could split it onto 2 nodes, have half your data in one node, half your data in another node, and you could lose 1 node and still have half your data. And by lose, I mean like the server falls over. Elasticsearch I haven't found to tip over yet. Even when you restart it, it persists all the data. So it keeps most of the data in memory and then flushes to disk occasionally. So you might lose some of the data, but you can also force it to use different storage systems. So by default, it uses memory and then puts it to disk every once in a while. You can also have it commit to disk on every single write. So it's a synchronous, like a blocking write to disk if your data is very sensitive. So replicas. Replicas define how many copies of your data you want. So similar to MongoDB, you can define how many replicas you want. And a replica is basically a clone that's stored in another server. So you can say I have 4 servers, I want 2 shards and 2 replicas. So that means 1 shard on each server, but you're going to have 2 shards on each server. You're going to have 2, 2, 2, and 2. And you could lose 2 nodes and maybe still have all your data. If you lose the 2 nodes that are both host the same shard, you're kind of out of luck. But hopefully that doesn't happen. So more replicas improves search performance because you have the work can be distributed. There's a master node as well that knows where all the shards are, and so the master node will delegate, say, oh, this is going to go to this node, this is going to go to this replica. So creating more replicas allows you to distribute the search load. So each replica contains the same set of nodes. So here we have 2 shards and 2 nodes. So we're going to put 2 shards in one node, 2 shards in another node. This cluster could expand up to 4 nodes, so we'd have 1 node with each shard, and 2 more nodes with one with each shard. And then we'd have 4 nodes, so we could lose a node and still have all our data, take a node down, do some maintenance, put it back up, and it would rejoin the cluster, and then we'd be back to good. Does that all make sense? Any questions about the sharding? No? All right. Multi-tenancy is something that I have to do at my job, so I spent a lot of time investigating it. There's 2 primary ways I've figured out how to do, well, I've discovered and found it online and figured out how to do with Elasticsearch. One way is you create 1 index for each tenant, which works for a while. But if you have a few million tenants, you have a few million indexes, this gets really hard to manage because you have a few million indexes. So sharding and replication become a problem because you have 3 million indexes, or 4 million, or 5 million. So if you have a small number of tenants that's not going to grow at an unbounded rate, then one index per tenant will probably work. So to do that, you can just change the index name when you do a search. So you can search my contacts, you could search Jose's contacts. But if you're going to do like a software as a service like idea, this might not be a good idea because you'll end up with millions of indexes. What you can also do is do special filter conditions. So you can use a filtered query, which will chop out everything that doesn't match the specific filter. So say you have an account ID or some sort of like unique identification that matches one account. You can also do multi-tenancy based on that. So you can say, give me all the, I want to do a search, but I only want to search the data for account 1. So do a filter on the data, filter everything by account 1, and then do a query. Problems with this, of course, it's far more error prone, because if you forget to put the special condition in, then you're searching everyone's data, and you've shown Jose's contacts to Mariano, and now Jose's spamming everyone Mariano knows. Totally do. This easily scales because you can have millions of account IDs, they're just numbers, and your shards and replicas stay manageable. You don't have millions of indexes that you have to split across multiple shards or multiple indexes. You should also make sure that your tenant is a non-analyzed ID. Your tenant ID is like a non-analyzed value, or it's a number. If you put a string like a UUID, Elasticsearch will be, hey, minuses, I'll just split that up into terms. And then when you search for UUID, it'll be like, hey, minuses, those must be multiple terms. I'll find everything that matches all of these numbers. Like, thanks. That's not what I wanted. Not at all. So use a number or use a string that doesn't have anything that Elasticsearch can interpret as a word divider, so no boundary conditions, so all numbers and letters, just one big blob. Or just tell Elasticsearch, don't analyze this data, please. I just want you to store it, so I can do filters on it. So to do this type of search, I can't do this one locally, but it does work. You should be able to do filtered, filter, and then do a term, and then you just want to look for account ID matching 1. And then the actual query we want to run is we want to look for purple Wi-Fi. So I want to find any invoices in my accounting index that are for account 1 that match purple Wi-Fi. Does that make sense as well? There's probably other strategies you can use to do multi-tenancy. These are the 2 that I found were the most useful. So there's more. Elasticsearch is a huge, huge, huge service. Huge in API-wise. Like the download's pretty small, but the features it has are quite numerous. So routing, as I explained earlier, lets you define how documents are sharded. When you index a document, you can give it a routing key, and then it will put it on the shard that matches that routing key. Rivers allow you to connect real-time services into Elasticsearch. So if you have a stream of data that you want to just dump into Elasticsearch, you can do that. There's a few built-in rivers. So there's one for RabbitMQ. There's one for MySQL where it just pulls the database and says, do this query, do this query, do this query, do this query, and then it will index the data. You can also, there's a built-in, I think it's a joke, but there's a built-in Twitter stream, so you can just pipe Twitter data into Elasticsearch and then search it. I think it's more for demos. You can also, there's a Thrift plugin. So if you have applications that are able to talk Thrift, or if you don't want to talk basic HTTP and would like to use Thrift, you can use that as well. If you don't know what Thrift is, that's fine, because you probably won't need it. Integration with CakePHP. There are a few existing plugins for CakePHP. I'm going to just briefly go over them. I don't have a ton of time left, and I'm not going to read readmes to you. There's really no point. Both the plugins have similar features, and they both do the same thing. And of course, you can make them do whatever you want. So the easiest integration with Cake, HTTP socket and JSON encode. It works. That's what I use. It will work. It's curl. It will work. You can also use curl. They work. It's pretty basic. There's not much, spit and polish to it. It will work. Not very friendly to use. And there's no magic. You can use David Kullman, who's Cake Hero on IRC. He produces an Elasticsearch data source. It has a behavior that allows you to auto-index models on aftersave. It also comes with a shell that allows you to run periodically and then index the data set. And there's also a data source, so you can build models that are backed by Elasticsearch instead of a SQL database. So you can do model find on Elasticsearch. So you can find that on GitHub right here. So he's got a README. Seems pretty straightforward. There were tests. Jose's contributed to it. This can't be that bad. Yeah. The next one is the Elasticsearch plugin by Kevin Van Sonnenfeld.
What do you think about the David Coleman?
The which? I thought it was nice. I like.
I wanted to add something that
Oh.
supports fixtures in Elasticsearch.
Oh, supports fixture.
Your data.
Oh, there you go. I didn't know that. I only got to as far as I can search, I can make models backed. That's a good idea. So Jose let us know that you can search, you can create fixtures inside Elasticsearch. So when you're running a test case, you can build a fixture and then do your search queries against fixture data. That's quite nice. So Kevin Van Sonnenfeld has similar features. One of the interesting things that this plugin has that the other one didn't have is you can just dump in gigantic SQL queries to do your indexing. So if you've used Sphinx before, I think Sphinx works on the same way. You give it a SQL query, it uses that to index it. So it allows you to work in a similar paradigm as to Sphinx.
Is this just looping that and creating?
Yep, that's exactly what it's doing. It runs that query. So this is for when you do an initial import. It runs that query and then just loops over the data and dumps it into Elasticsearch. And then it also allows you to do search filter, after save, so real-time updates. So whenever you save an index, save a model, it will update the index as well. Yeah, so you can also do it with contain, and you can do highlighting. So this looks very much like most of the plugins don't provide a ton of wrapping on top of the Elasticsearch API because it's a really nice API that kind of matches, really blends really easily with a lot of applications. So that's actually what you just feed into Elasticsearch. So if you were to JSON encode that, you could just dump it into command line and send it to Elasticsearch. So that's kind of nice. So that's pretty much it. Does anyone have any questions? No? All right. So you're all just going to go and set up Elasticsearch tonight? I've tried several times. The problem that I have at work is getting it through operations. My operations guys are really, really busy. But yeah, I've loaded up over just under 2 gigabytes of data, and to replace a MySQL database that frequently locks up and has numerous problems. It's actually really slow. So I built a prototype. I was like, hey, look, we could do this. And you could have real-time searching, so as you're talking to people on the phone, you can find their data. It worked perfectly. It took me an afternoon to set up. So it's surprisingly easy to use. You feel like a wizard when you use it. No, the ops team? No, I have a good relationship with them. They were more disappointed, like people were more disappointed we couldn't just drop it into production right now. That was the biggest disappointment. But yeah, we also use it on CakePHP, so the documentation, all the doc search are done through Elasticsearch. And so if you want to find an easy way to get started with Elasticsearch, you can actually download the cookbook, download the doc search application that's in the CakePHP organization, set them both up locally, and then you can run the book with Elasticsearch locally so you can kind of see how we did it. It's not a super advanced setup, but it works. Yeah. All right. If there's no other questions, I'm done. Okay. Thanks. And I'll have the slides up on SlideShare soon.